Sai Ram. Dear learners, welcome to part 5 of class 8th mathematics chapter playing with numbers. Let me give you a trick. If I ask you what is 25 multiplied by 11, find the answer separately and write it. I'll directly tell you, you write 2 and 5, add these two, 7. Just check it up also. 25 into 11. 11 5s are 55. 5 carry. 11 2s are 22. 22 plus 5 is 27. What am I saying? Suppose it is 43 multiplied by 11. Just write 4 and 3 and leave a gap in between. And in between, you will just write down the sum of 4 and 3. 4 plus 3 is 7. Check it. 43 multiplied by 11. 11 3s are 33. 3 carry. 11 4s are 44. 44 plus 3 is 47. Isn't it magic? Let's take some more. 72 multiplied by 11. I'll just write down 7 and 2, and in between addition of these two. 7 plus 2 is 9. Check it also. 11 2s are 22. 11 7s are 77. 77 plus 2 is 79. Let me take some more. 83 multiplied by 11. 8 and 3 we write down here. In between, what are we supposed to write? Add these two. 8 plus 3 is 11. Now it is a 2-digit number. So we will only write 1 here and increase this digit by 1. So it will become 913. So I'll rub this, I'll erase it and write down 913. Check it also. 11 3s are 33. 11 8s are 88. 88 plus 3 is 91. Another one. Suppose it is 79 multiplied by 11. We'll write down 7 and 9. And in between what will come? Add 7 plus 9. 7 plus 9 is 16. 6 here. And 1 will come here. So instead of 7, what will we write? We will write down 8. So this will be actually 869. One last one. 97 multiplied by 11. We write down 9 and 7. Add these two. 9 plus 7 is 16. 6 will come here and 1 will be added to 9. So this will become 10. So actually the multiplication would be 1067. The product will be 1067. Dear learners, today we will be talking about tests of divisibility, which you have been studying for quite some time now. Divisibility by 2. Any number. How do we find it out whether it is divisible by 2 or not? All even numbers, they are divisible by 2. And what are even numbers? Even numbers are those numbers which will end with 2 or a multiple of 2. So if there is any number which ends with 0, 2, 4, 6 and 8, then the whole number will be divisible by 2. If I take some number 4370, is it divisible by 2? Yes, we only have to see the units place. It is 0, unit place is 0, so it is divisible by 2. We do not have to even check for other digits. What about 7873? Is it divisible by 2? No, it is not divisible by 2 because it ends with 3. It does not end with an even number. Let me take a bigger number. Will it be divisible by 2? You only have to see the last digit. It is 8. Yes, it will be divisible by 2. And how do we check the divisibility by 3? To check the divisibility by 3, we add all the digits of the given number. For example, if the number is 111, we will add all the digits. It gives us 3. If the sum of the digits is divisible by 3, the whole number will be divisible by 3. Let's take more examples. 436. Add 4 plus 3 plus 6. What do we get? 13. Is 13 divisible by 3? No. So, number 436 will not be divisible by 3. What about 4275? Add them. Add all the digits. 4 plus 2 is 6. 6 plus 7 is 13. 13 plus 5 is 18. Is 18 divisible by 3? Yes. So the whole number will be divisible by 3. You can verify it also. Do the division by long division method and see. We bring down 7 here. 3 2s are 6. 1 is remainder. 5 comes down. 3 5s are 15. So, rather than dividing the whole number, if we want to know whether a particular number is divisible by 3, what are we going to do? We are going to add all the digits, and if the sum of the digits is divisible by 3, the whole number will be divisible by 3. Now, how do we find the divisibility by 4? We had already checked up. For 2, the last digit has to be 0, 2, 4, 6, 8. For 4, what you have to see is the last 2 digits, whether it is a 2-digit number, 3-digit number, 4-digit, 5-digit, any number of digits could be there. If the last 2 numbers are divisible by 4, then the whole number is divisible by 4. Let's take examples. 248. You just have to check last 2 digits. Last 2 digits, 48. Is 48 divisible by 4? Yes, it is divisible by 4. 4 1s are 4 and 4 2s are 8. So if last 2 digits are divisible by 4, then the whole number will be divisible by 4. Let me take 3724. You only have to check for last 2 digits. Is it divisible by 4? Yes, it is divisible by 4. So the whole number will be divisible. Cross check it. 4 9s are 36. 4 3s are 12. 4 1s are 4. So we do not have to divide it completely. Just check for the last two digits. What about 5710? The last two digits are 10. Now, will it be divisible by 4? Is 10 divisible by 4? No, 10 is not divisible by 4. So therefore 5710 will also not be divisible by 4. Let's divide and see. 4 4s are 16. 4 2s are 8. 30. 4 7s are 28. So we get remainder 2. It is not divisible. Now what about if I have got 21,200? Is it divisible by 4? Yes, please do remember, whenever the last two digits are 0, the given number will be divisible by 4. Again, check it. 4 5s are 20. 4 3s are 12. 2 zeros are there. They'll go here. So if any number has got last two digits 0, the whole number will be divisible by 4. And the ground rule is divide the last two digits of any given number by 4. If it is divisible, if the last two digits are divisible by 4, then the whole number will be divisible by 4. Now let's come to divisibility by 5. This one is easy. You have been doing it. If any number has got 0 or 5 at the end, then the whole number is divisible by 5. Number is 2000. Is it divisible by 5? You only have to see the last digit. Last digit is 0. Yes, it will be divisible by 5, and you will, if you divide 2000 by 5, you will get 400. 7235. Will it be divisible by 5? Yes, it will be divisible by 5 because the last digit is 5. I said the last digit should either be 0 or 5. Then the whole number is divisible by 5. You can divide 7235 by 5 and see it. 5 ones are 5. 2 comes there. 5 fours are 20. Again 2 comes there. 5 fours are 20 and 5 sevens are 35. So any number, let me take a bigger number. Is it divisible by 5? Yes, it will be divisible by 5 because the units, at the units place, we have 0. So any number having 0 or 5 at the units place will be divisible by 5. What about 6? Now you already know the divisibility rule for 2 as well as for 3. So what are you going to do? You will check the divisibility of the given number by 2 and then check the divisibility of the given number by 3. If any number is divisible both by 2 as well as by 3, then the given number is divisible by 6. If it happens that it is only divisible by 2 but not by 3, then the given number will not be divisible by 6. Or vice versa, given number is divisible by 3 but not divisible by 2, then the given number again will not be divisible by 6. Let me take this example. $3,660. First check for divisibility by 2. Add all of them. 3 plus 6, 9. And 9 plus 6 is 5, 5, 9 plus 6 is 15. So sum is coming 15. Why are we adding it up? To check the divisibility by 3. And before coming to divisibility by 3, what about divisibility by 2? Is it divisible by 2? Yes, it is divisible by 2 because at the units place we have got 0. For divisibility by 2, just to remind you that we should have either 0, 2, 4, 6, 8. If these numbers or these digits are at the units place, then the whole number is divisible by 2. So 3660 is divisible by 2. For checking the divisibility by 3, we just add them, and by adding we have got 15. Since 15 is divisible by 3, now we see that 3660 is divisible both by 2 as well as by 3. Therefore, this number is divisible by 6. You can check for any other number also. Is it divisible by 2? Yes, it is divisible by 2 because we have 2 at the units place. We can have 0, 2, 4, 6, 8 at the units place. Then only the given number will be divisible by 2. Now for 3, we need to just add all the digits. 6 plus 2 is 8, 8 plus 8 is 16, 16 plus 3 is 19. So this number is not divisible by 3. So hence the given number 8362 will not be divisible by 6. What about divisibility by 8? Divisibility by 8. If you see divisibility by 4, we looked at the last 2 digits. For checking the divisibility by 8, we will look at the last 3 digits. For 2-digit numbers, you can multiply by 8 and see whether it is divisible or not. For example, 48, 8 6 are 48. Check it in this way. What about 848? 848, we'll have to check it up by dividing. 848, divide it, and we will get the remainder 0 in this case. Let me do it. Eight ones are 8. 4 comes here. 8 also comes here. 8 6 are 48. For 3-digit number, you are multiplying it. Suppose this number was like this. 2,46,848. Now you want to check whether it is divisible by 8 or not. So rather than dividing the whole number by 8, you only check for last 3 digits. If it is divisible by 8, then the whole number will be divisible by 8. Check for any other number also. $7,240. So rather than checking for the whole number, you only see the last 3 digits. The last 3 digits, are they divisible by 8? Yes. 8 3s are 24. We'll get 30 as the quotient with remainder 0. So this number is divisible by 8. What about divisibility by 9? It is similar to the one that we have done for 3. What did we do for 3? Add all the digits and then we checked whether the sum of all the digits is divisible by 3 or not. In this case, what we will see is the sum of all the digits divisible by 9 or not. If it is divisible by 9, we will say that the whole number is divisible by 9. For example, 3476. Let us check whether it is divisible by 9 or not. Add them up. 3 plus 4 is 7. 7 plus 7 is 14. 14 plus 6 is 20. Now 20 is neither divisible by 3 nor by 9. So this is not divisible. What about 3471? 3 plus 4 is 7. 7 plus 7 is 14. 14 plus 1 is 15. We get the sum of all the digits 15. So is it divisible by 3? Yes, the number 3471 is divisible by 3, but it is not divisible by 9. So therefore 3471 will not be divisible by 9. What about 3474? What is the sum coming? 3 plus 4 is 7. 7 plus 7 14. 14 plus 4 is 18. Is 18 divisible by 9? Yes, it is. So this number will be divisible by 9. Check it also. 9 3s are 27. 14 minus 7 is 7. 9 8s are 72. 9 6 are 54. So for checking the divisibility by 9, add all the digits in the given number and divide by 9. If it is completely divisible, we will say that the whole number is divisible by 9. Divisibility by 10, very simple. If any number ends with 0, that number will be divisible by 10. 2780. Is it divisible by 8? Sorry, is it divisible by 10? Yes, it is divisible by 10. Any number 75,290. Is it divisible by 10? Yes, it is divisible by 10. If a number has got 3 zeros at the end, yes, it is divisible by 10. You only have to check the last digit. Is it 0 or not? If it is 0, yes, it is divisible by 10. What about 575? Is it divisible by 10? No, it is not divisible by 10 because the last digit is 5. It is not 0. Let's try the following questions. If the division n divided by 5 leaves a remainder 4, what might be the ones digit of n? What is the question? Let's first see that. N is divided by 5. When n is divided by 5, we are getting the remainder 4. And they are asking us what might be the ones digit of n. First of all, let's go back to the rule. Any number, when will it be divisible by 5? If it ends with 0 or it ends with 5. That is what we have done. Any number, if it ends with 0 or 5, then the entire number will be divisible by 5. Now we want remainder 4. How will we get remainder 4? Just add 4 to it. So what might be the ones digit of n? Ones digit of n would be either 4 or 9. Let's take a very simple example. say 14. We divide it by 5. What do we get? 4 is the remainder. Let's take another one which ends with say 9. Let's divide by 5. 5 4s are 20. 5 7s are 35. Remainder is 4. So we have cross-checked our answer. Next question. If the division n divided by 5 leaves the remainder 2, what might be the ones digit of n? Similar to last question. If it was completely divisible by 5, that means if the remainder was 0, we could have 0 or 5 at the units place or at the ones place. We want remainder 2, so add 2 to it. So what is our answer? Answer is 2 or 7. And you can check it also. Let me take a simple number, 12 divided by 5. 5 2s are 10. We get remainder 2. Let's take a number which ends with 7 divided by 5. 5 5s are 25. Remainder is 2. Any number you take which ends with 2 or 7, when it is divided by 5, it will give remainder 2. Question 3, now you should be able to do. If the division n divided by 5 leaves remainder 1, what might be the ones digit of n? Same way, if it was completely divisible by 5, the units place would be 0 or 5. But we have remainder 1, so add 1 to it. So we get the answer 1 or 6. These could be the only 2 digits at the ones place. You can take example also. For example, 11. 11 divided by 5. We get remainder 1. Take another example. 26 divided by 5. We get remainder 1. 5 5s are 25 and 1 is the remainder. Another question on similar lines. Division of n by 2 leaves remainder 1. First you have to see if the number is completely divisible by 2, what would be at the units place? Just remember, try to remember. Any number which ends with 0, 2, 4, 6 or 8 would be divisible by 2. Now they are saying that remainder is 1. So add 1 to each one of them. What do we get? 1, 3, 5, 7, 9. So what might be the ones digit of n? Ones digit of n could be 1, 3, 5, 7 or 9. You can take any example to cross-check your answer. 43 divided by 2. What do we get? What is the remainder? 1. Take any number which ends with 1, 3, 5, 7 or 9. The remainder will be 1. Let's look at the next question. If the division of n by 2 leaves no remainder, n divided by 2 and remainder is 0, what might be the ones digit of n? The answer is already there in the previous question. Ones digit would be 0, 2, 4, 6 or 8. If any number ends with any of these 5 digits, the entire number would be divisible by 2, leaving 0 remainder. Let's take a few more questions. Check the divisibility of this given number by 9. Just recall the rule. We have to add all the digits. 2 plus 3 plus 3 plus 6 plus 7 plus 8 plus 7. Add them up and see what is the value coming. 3 plus 2, 5. 5 plus 3, 8. 8 plus 6 is 14. 14 plus 14 is 28. 28 plus 8 is 36. Whatever is the sum, divide that by 9. Is it getting completely divisible? Yes, it is getting completely divisible. Since the sum of all the digits is getting completely divisible by 9, we will say the given number, which is 23,36,787, is divisible by 9. We don't have to divide the entire number to check it. Just add all the digits. If the sum of the digits is divisible by 9, the entire number will be divisible by 9. Question number 7 is exactly to be done on the same lines as question number 6. Add all the digits. Just see what is the sum of the digits coming. 3. 1 plus 2, 3. 3 plus 5 is 8. 8 plus 8 is 16. 16 and here it is 7 plus 3, 10. 16 plus 10 is 26. And 26 plus 5 is 31. Now, is 31 divisible by 9? No, it is not divisible by 9. Therefore, the given number is not divisible by 9. Check the divisibility by 3. Again, the same method. Add all the digits in the given number and check whether the sum is divisible by 3 or not. What is the sum coming? The sum 15 plus 5 is 20. 20 plus 10 is 30. 30 plus 3 is 33. So 33. Is 33 divisible by 3? Yes. If 33 is divisible by, if the sum of all the digits is divisible by 3, then the entire number, that is, the given number is 78,56,412 is divisible by 3. Isn't it simple? Now do question number 9. Add all the digits in 78,251. Check what is the sum of digit coming. (18 plus 5, 23). Is 23 divisible by 3? No, 23 is not divisible by 3. So therefore we will say 78,251 is not divisible by 3. So I hope You now know how to apply the divisibility rules for checking the divisibility of various numbers. Let's take this one. It is given that the number 21y5 is a multiple of 9. It is already given that it is a multiple of 9. So that means it is completely divisible by 9. We have to find what is the value of y. So going back to the divisibility rule for 9, add them up. So it is 8 plus y. For a number to be divisible by 9, the rule was that the sum should be divisible by 9. Now what should I add to it? What should I add to 8 so that it is divisible by 9? I can make it 8 plus 1. 8 plus 1 is 9. Can I have any other number which is divisible by 9 when I add 8 to it? If I put 2 in place of y, I'll get 10. 10 is not divisible by 9. Put any other number. Maximum number that you can put is 9. 9 plus 8 is 17. 17 is not divisible by 9. So 1 is the only number that can be put here. So what is the value of y? Value of y is 1. And what is the number that we get? We get 2115. And what about 2115? You can add it again. All the digits. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 5 is 9. And 9 is divisible by, the sum 9 is divisible by 9. Hence the whole number 2115 will be divisible by 9. You can check it up by long division method also, but that is not what is required. It is only for your own curiosity that you can do it. 9 3s are 27. 9 5s are 45. So remainder is 0. Same way, find out the value of z in this. 31z5 is a multiple of 9. That means this number is divisible by 9. We will add all the digits. We get 9 plus z. So what could be the values of z so that the sum is divisible by 9? What if I put z equal to 0? If I put z equal to 0, 9 plus 0 is 9. It is divisible by 9. Can I put any other number? What about putting z equal to 9? I get 9 plus 9 is 18. Let's try. 3105. Is it divisible by 9? 3 plus 1 is 4. 4 plus 5 is 9. Yes, it is divisible by 9. What about number 3195? 3 plus 1 is 4. 4 plus 5 is 9 and 9 plus 9 is 18. So even this is divisible by 9. Just curiosity's sake, divide it separately by 9 and see whether it gets completely divisible or not. Let me try to do it orally. 9 3s are 27. 4 goes there, it becomes 40. 9 4s are 36. Again 4 goes there, 9 5s are 45. So this is the quotient we get when 3105 is divided by 9. What about 3195? When it is divided by 9, the quotient that we get is 9 3s are 27. 4 goes to the other side. 9 5s are 45. 4 goes there. 9 5s are 45. So here we have got the quotient 355. You do not have to divide. You are not supposed to cross check the answer. But since we are at the stage of building up the concept, so that is why we are dividing and seeing it. By the end of this chapter, you should be thorough with the divisibility rules. Again, try this question. 2 4x is a multiple of 3. So what we are going to do? We are going to add all of them. So 6 plus x. Now this is divisibility by 3. So whatever is the answer, it should be the sum of all the digits should be divisible by 3. Let's put x is equal to 0. What sum are we getting? Sum of digits. Sum of digits is 6 plus 0 is 6 and it is divisible by 3. Can we have another answer also? Put x is equal to 3. Then sum of digits is 6 plus 3, 9. So we can have the number 240. And if the number is 243, then also it is divisible by 3. Both 240 and 243 are divisible. Can we have some other digit also? Put x is equal to 6. Then what is the sum of digits? It is 6 plus 6, 12. Yes, it is divisible. So that means we can have 246 also. Then another digit is also left. So if we put x is equal to 9, we'll get 6 plus 9 and 6 plus 9 is 15. And 15 is divisible by 3. So we can have 249 also here. $249. So what are the values of x that we can have? Values of x are 0, 3, 6 or 9. This is our answer. Next question. We have number 31z5 and it is given that it is a multiple of 3 where z is a digit, and what could be the values of z? Same method, 3 plus 1 plus z plus 5. So it is 9 plus z. So what should we put z equal to so that 9 plus z, whatever sum we get, that is divisible by 3. So first thing is 0 only. You put 0, we will get 9 plus 0 is 0. What about 3? 9 plus 3 is 12. Yes, it is also divisible by 3. Then we will put 6 also. 9 plus 6 is 15. It is divisible by 3. Then z equal to 9 and 9 plus 9 is 18. So what are the different values that z can take? Z can take values 0, 3, 6 and 9. The four digits that we will be, the four numbers that we will be getting after putting these digits are 3105, 3135, 3165 and 3195. All these numbers are completely divisible by 3, leaving remainder 0. So dear children, what have we studied in this chapter? With this we have come to the end of this chapter. In this chapter, what have we studied? To begin with, we had studied the concept of place value, how a given number can be written in extended form, and this is a concept that you had studied in primary classes. After that, we had done some tricks involving 2-digit and 3-digit numbers, and then the explanation also, or logically coming to a conclusion, how do those tricks work. Then we solved puzzles using letters in place of digits, and we had to identify what could the values of those letters be. Last but not the least, we did divisibility rules for 2, 3, 4, 5, 6, 8, 9 and 10. Quickly taking you through that. Any number which ends with 0, 2, 4, 6, 8 is divisible by 2. Any number, if we add all the digits, if the digits are divisible by 3, then the entire number will be divisible by 3. For 4, we check the last 2 digits of the given number. If the last 2 digits are divisible by 4, then the entire number will be divisible by 4. Any number that ends with 0 or 5, it will be divisible by 5. Any number which satisfies the divisibility rule for 3 as well as 2 will be divisible by 6. Any number in which the last 3 digits are divisible by 8, then the entire number will be divisible by 8. For 9, we add all the digits in the given number. If the sum of the digits is divisible by 9, the given number is divisible by 9. And for 10, if the last digit of the given number is 0, then the entire number will be divisible by 10. So that is all that we have in this chapter. Thank you so much. Om Shri Sai Ram.